Okay, so let's look at the solution for the second practice problem on hydrograph separation. We're given some data here from a creek in Alaska. It's 9 days worth of data. We show a beautiful event hydrograph, and our task is to separate the event flow from the base flow using the Dingman A method and the Dingman B method. So first thing we need to do is to locate the point on the hydrograph where the event part starts, and I'm going to just locate that, just use it, find about right about in here. Right, we can just eyeball that. Next thing we're going to want to do is put a vertical line right through the peak of the hydrograph to note the time at which the peak occurs. There we go. It occurs at about 3.4 days. And then we're going to use the formula that we use to calculate the end of the event hydrograph, which is calculated as a time from the peak based on the area of the watershed in square kilometers. So first thing we need to do is to convert the area from miles squared to square kilometers. We'll use the convert function. There we go. And now we're going to plug into the formula that the number of days after the peak is equal to 0.2 times the area of the watershed in kilometers to the 0.2 power. So let's calculate that here. We'll just call that D. That's a time in days, and that will equal 0.82 times I2 and it's equal to 2.16 days. At this point, there's a couple ways we can do this. The easiest probably is to note that the peak occurs at 3.4 days, and the extra lag, this is the peak, right? And the extra lag is 2.16 days, so the total distance from the beginning of the record here, the T, will equal the sum of these, which is N9 plus N10. So it's approximately 5.6 days after the beginning of the record, and we can find that, and I'll put a little mark on here. 5.6 is right about here. All right, and so now all we need to do is to draw remember we're going to do two things here. We're going to continue the recession curve that precedes the event hydrograph, just sort of do our best job of extending a straight line down back to the peak line. And then we're going to draw another straight line from the intersection of that extension in the peak line with that end of the event hydrograph point that I drew. And there we have it, the separation between event flow and base flow. Now, the second method we're going to use is the one where we have to extrapolate the recession that occurs after the event back under the hydrograph. And to do that, we need to copy our graph and replot it with a logarithmic y-axis. So I'm going to copy my graph, find some new part of my screen here, and I'm going to paste it. And there it is. And now I'm going to change my y-axis to logarithmic. You'll also see that I can change here the axis, and there we go. So there is my hydrograph plotted in a log normal axis. Once again, I'm going to find the peak and mark that on the hydrograph. And now, remember, what I need to do is extrapolate that recession that occurs after the end of the event hydrograph back under the hydrograph, with the assumption that it's that's an exponential decay curve, which will plot as a straight line in the log normal graph. So what I'm looking to do is extend, and you can see it looks really pretty good over here. This part of the graph here looks pretty darn linear, right? So that's the part I'm going to want to extrapolate. So I'm going to use a straight line to do that. And when I extend it back, it looks really quite good, the linear part, right? And when I extend it back, it intersects the peak at a discharge of looks like about 70 CFS. I just want to make note of that intersection of the recession, extension of the recession, and the peak line. So back to our original drawing, I'm going to mark that point, the intersection of the peak line and 70, which is right about in here. And now I'm going to do two things. I'm going to draw a straight line from the initial red dot to that here. I'll even just eyeball it here the best I can. That's going to be the first part. And then the second part, I'm going to try to recreate that exponential decay curve, that curved line, which goes back from here. And obviously, I'm not very good at this, but I'm going to try to go back and then join. I'll try this again. that curved line that goes back and joins the recession following the event. And so there we go. There's our second method of separating the base flow from the event flow. In this particular case, it's not obvious which yields a greater amount of event flow. The first method yields more event flow near the peak, but it ends the event sooner, where the second method extends the event sooner, but has more base flow underneath the peak and less event flow. But there are two different ways of doing it, and there you go.